Semiconductor manufacturing invites a contrast of scale. Enormous fabs, each spanning hectares, containing an automated material handling superhighway more than 30 kilometers long, and comprised of thousands of specialized tools, are designed to produce chips housing billions of microscopic transistors. It's where kilometers meet nanometers. This contrast becomes more profound when the relationship between process technology and infrastructure is magnified across the global supply chain. Satisfying the demand for semiconductors requires collaboration on a planetary scale. For instance, building a typical smartphone can involve factories and firms in the US, Germany, Japan, China, Korea, Malaysia, and Taiwan, among other countries. Widen the lens on this supply chain to include the suppliers of advanced manufacturing equipment and necessary materials and chemicals, and the breadth of the mutual dependencies becomes even more astounding. These locations each play an interconnected and imperative role, whether in the design, commercialization, or manufacturing of products. Semiconductors are built using some of the most advanced machinery on Earth. A single facility may house tens of thousands of units of specialized manufacturing equipment, and each of those machines is comprised of thousands of extremely sophisticated components and subcomponents, each with their own supply chains. Consider the most advanced photolithography exposure tool, known as an EUV tool. Described once as the most complicated machine humans have built, a single EUV tool contains hundreds of thousands of parts and 2 kilometers of cabling from nearly 800 global suppliers. The intricacy of the entire semiconductor supply chain is incredibly complex. Coordinating the control of chemicals across this landscape is tremendously difficult. Tools must perform specific functions at specific steps. The right chemicals must be delivered to the right place in the right quantities at precisely the right moment. The need for control extends to the molecular level. Every gas or liquid that touches a wafer must have its impurities controlled to levels less than a few parts per billion or even per trillion. How small is that? It's equal to 1 drop of water in 20 Olympic-sized swimming pools.
Any type of impurities in the chemicals that we provide to the semiconductor companies are detrimental to the semiconductor manufacturing process. So ideally, we'd have a molecule that has no impurities in it. It would just be a pure molecule. Well, that's impossible in creating these molecules because there's byproducts. So we remove those impurities through purification processes. We analyze those chemistries to prove that we've removed them, and then we provide that certificate of analysis and surety to the semiconductor companies that what we're providing them is exactly what we say we're providing them so they can meet the requirements that they have.
Today's transistors are starting to be measured in nanometers. Any impurity present, even at this atomic level, can result in malfunctioning devices. The required level of strict quality has necessitated increased use of cleanroom controls by suppliers during chemical manufacturing to protect both the finished product and workers involved in the manufacturing process. Maintaining this level of control at the fab depends upon systems that separate and protect the processing of the wafer from external forces. Each tool and every chemical that passes through them, from the moment of installation, is part of a closed system designed to help protect the integrity of the chemicals, eliminating the introduction of dirt, light, and moisture, and to isolate workers from chemical exposure. Extensive risk management measures, often going above and beyond regulatory requirements, are in place, the result of extensive collaboration between suppliers of process tools and chemicals and semiconductor manufacturers. Ensuring the reliable flow of innovative chips that drive our world while protecting workers and the environment is only possible thanks to international cross-industry collaboration. Collectively, the entire semiconductor ecosystem is committed to keeping the wheels of an astonishing global supply chain turning smoothly and safely. Next, we'll review how the industry protects the most important component of the chip manufacturing process: its people.